So guys, in that last video we have discussed about what is meant by admissible curve, then extremal, then we have also got some flavor of functional. What do we mean by functional? Now observe that suppose I is equal with this integration where functional it is involved here, and look at, obviously it is a function of x, y and y dash. Okay, now the question is, you need to find that extremizing curve or particularly that curve which along which this I possesses its maximum or minimum value. Okay, that is the thing. So to give the answer, you need to use a certain formula which is called as Euler-Lagrange's equation. Okay, for net exam, particularly for net exam, you need to remember this formula, and all the questions are based on this formula, which is del f del y minus ddx of del f del y dash equals to 0. So this is the primary formula you need to remember. Okay, and immediately you can relate that this is a differential equation. So to find the curve or to find the extremizing curve explicitly, you need to have some boundary conditions in your hand. For that purpose, suppose fixed boundary condition will be given to you or moving boundary condition will be given to you, and all these things you will be provided, okay, in that exam hall or in the question. Fine, and we will also discuss that type of questions in the subsequent videos. Now look at, this is your Euler-Lagrange's equation. Here some cases may occur that suppose your function f, some particular case, take all these three cases we will discuss here, note it down, and it will be helpful for you and it may save your time as well. Suppose your f, x, y and y dash, this is a function, and this function it is independent of x. In that case, particularly in that case, this formula reduces to this formula, f minus y dash f y dash equals to constant. Particularly this formula helps a lot, and you need to remember this formula to implement in such problems. Otherwise those type of problems get very lengthy to solve in the exam hall. Definitely you need to use this formula if that functional is independent of x. Now if this function f, x, y and y dash, this is independent of y, this is independent of y, in that case look at this del f del y, it turns out to be 0. That immediately implies that your ddx of del f del y dash equals to 0. So this is another form and there is nothing special with it, but this formula it is very important. Please remember it and you will get the flavor when we solve some questions. Now if f, x, y, y dash, this functional it is independent of y dash, then immediately you can get the flavor that this term, that means del f del y dash, it turns out to be 0, and in that case only this term survives and it is del f del y equals to 0. That means only this term equals to 0. So there is nothing special with these two formulation, but this is very important, you need to remember. Okay, so this is one part of the story. Now the thing is, suppose we are saying this I possesses its extremal value, or in other words it can pause or it can take its maximum or minimum value. So is there any certain kind of condition which immediately imply whether along the extremizing curve I possess its maximum value or minimum value. Obviously there is a formula, namely you can relate that formula by your 12th class knowledge of maximum minimum value. Whenever suppose along that particular curve, if y dash, okay, you need to find f of y dash, then if this one is greater than 0 along that curve, you will say that given I, it attains its minimum value along this curve. Okay, you can easily relate, and if it is less than 0, you can say it attains its maximum value along that curve. Okay, now the question is about strong minima, strong maxima, and all this. I think you have heard these terms, but we will discuss via some question that will be suitable for you. Okay, and namely there is a condition which is called Weierstrass condition, and we have to use similar kind of formulation is there, but via some question we will discuss that part as well.